And I'm going to ask you stuff on testing that has to do with these polynomial spaces. So that's another reason why I'm trying to take my time here. Because in the past, I feel like students have found this to be like, whoa, what's going on? Where are all the matrices? B, find the coordinate vector of P of t, which is 2t squared minus 3t plus 1 relative coordinates relative to B. So same B. I hope you see we could just solve 1, 1, 0, 1, 0, 1, 1, 1, 1. I'm copying down that matrix. C1, C2, C3 equals, now which way? A was my constant term. So I actually have to put the 1 first, the -3 second, the 2 third. From the way I set this up, right? A was the constant, B was the t, right? And I just want to compare. This is just P sub B. This is like, I guess I should say just like, the coordinates under a different basis. And this is sort of like coordinates under a standard basis coordinates. I know I'm kind of making a little bit of a jump here, but I think it's worth comparing to that formula up above. And maybe instead of putting x here, sorry folks, these are polynomials. So we have the polynomial in B coordinates and standard coordinate. Now, I'm not going through the steps of solving that, you check. So here we would want to find specific values of C1 and C2, C3. We either need an inverse or we need to go through augmented matrix process. What we get is C1, C2, C3 is -1, 4, -2. And all right, I'm going to stop. And we'll finish this handout. And if you want the 4.5, I brought it. But you can wait till next time if you'd rather wait. Here it is. Next time we'll start talking about dimension of a vector space. So, and you'll have homework from me, right, on Friday.